Good morning. Yes, you can do that. Just fill out the doodad, okay? Good morning, welcome back, Gwen. You can open up the slideshow for today. Kyle is back. John, Julia, Connor. Okay, please open up the slideshow for today. Why are we yelling?
I'm trying to work it out. Oh,
Oh, good morning.
I just died like a weekend.
Listen, I told everybody in Miss McCain's class yesterday, I had those when I was a kid. Oh my God, those were the coolest.
They're fun, huh?
Oh my gosh.
Newton's third law of motion.
Don't know where everybody is.
We lost Kyle.
Where's Scott?
Oh no, Kyle went to the bathroom. I'm saying I don't know where everybody on Zoom is. Like, where are you? I miss your faces.
Kyle was just quick.
And he was like, he had to go potty, so.
He put up a whole bunch of balloons and then ran.
He was with us. He was with us today.
Yeah, he
He was
popped
with
like
us and then we
7
couldn't see
balloons.
him.
And then you couldn't see him?
You're like,
He turned the corner.
Is he like Houdini or something?
yeah, better.
He turned the corner and we didn't see him.
Okay, let's open up the slideshow. I literally have no idea where everybody is. Like, where are they? We're gonna get started though. So let's take a look at this activity here on the next slide. Okay, so today it's officially like the start of the algebra unit for input output. Or functions is another word for it. Friends at home, please make sure you open up the slideshow. So let's take a look at, ooh, that's stuck together. Okay, so we're looking at slide number 2, okay? And we have this bagel shop, okay? And a customer at a bagel shop is buying 13 bagels, okay? The shopkeeper says that it will be $16.25. Where is everybody?
That's a question.
It's a question. Where is everybody? So the shopkeeper himself says it's going to be $6.25, using this table here as his justification. Well, it's not really a table, but it's like the price list. Okay. Jada, Priya, and Han, who are at the shop, all think that it's a mistake. Jada says that to her friends, shouldn't the total be $13.25? Priya says, I think it should be $13. Han says, no, I think it should be $11.25. Explain how the shopkeeper, Jada, Priya, and Han could all be right. So all 4 of these people are correct when they say the price that they have, but each person took a different route to get to that total price. Using this table here of the prices and things, please look through. I'm really confused as to where everybody is. Looking at this table of prices for things, tell me, how is the shopkeeper right? How is Jada right? How is Priya right? And how is Han right? You're taking 2 minutes right now to identify what combination of prices would get each one of these friends to be right. Then if you finish early, I don't want you to move on to the table. Okay, so just stay here for 2 minutes to work on this.
Miss Jermaine, I think they're still in the tech ed classroom because he didn't dismiss us.
He didn't dismiss you? Okay, I think people are coming in now. Wouldn't the fact that he walked out of the room sort of be an indicator?
He left that classroom and it was like weird.
Oh, you guys were in the cafeteria?
We were in it for like 5.
I mean, he said they can go and chill and join their Zoom.
Yeah, he did say that we should do
Okay, people that are just coming in, I'm on the slideshow. I'm not going through the directions again. You are reading through the directions on slide number 2 when you're getting started. I'm getting started in about a minute and 12 going through this. You're on slide number 2 and you're getting started on talking about how each one of these people is right when they say how much they paid. Because if you look at this table of the prices, there are different combinations that would add up to those different prices that each person said. Okay, Max isn't here. Tyler isn't here. And I don't have the opportunity. Perfect. Here we go. We're taking another 5 for ourselves. Okay, here we go. I'm looking at this guy. What would, if we look at the combination that the shopkeeper said, he said 13 bagels would cost me $16.25. What did he do to get that $16.25? Kyle. He said the price of one bagel, and he multiplied by 13. Very good. We're getting into the slideshow. Let's get started. Let's get moving here. Jada, she said that the total is going to be $13.25. What did she do? What was her combination that got her to $13.25? Connor.
She did 6 bagels plus 6 bagels plus 1 bagel.
Very good. He did, so the price of 6 bagels, I'm going to say 6B, and then we multiplied it by 2 times 2, and then she added what?
1 bagel.
The price of 1. Good. Does everyone at home see what we're doing here, please? Let me know in the chat. I don't have anybody giving me anything in the chat. Is everyone understanding and following what we're doing? Thank you, Abby Wasta. Okay, so now Priya said it's going to be $13. What did Priya do to get that price of $13? What combination would get you $13? John, what were you thinking for this one?
9 bagels and 4 for the price of 1.
Very good. The price of 9 bagels, 9B, and then she added to that the price of 1, and then what did she do to that price of 1?
She multiplied it by 4.
Times 4. Very good. I'm going to ask again. Are you guys at home following along? Are you guys in here following along? You're getting what we're doing here? Good. Now, Khan is my last friend here. He said it's only going to be $11.25. Kyle, what were we thinking for that one?
He took the price of 12 bagels and added.
The price of 12B. So that's 12B price. And then he added the price of 1B. Okay? So look at all these different combinations that are going to get me to 13 bagels. 13 different price combinations. If I buy 13 bagels, I have at least 4 different price combinations here. Does everyone see like what I'm saying here? So this input of 13 bagels, how many outputs does it have? How many different combinations or outputs does it have? Yes, 4, at least 4 different combinations. So is this guy going to be a function? No. If we say a price of 13 bagels and we try to write it, when we say 13, the number of bagels, 13, price, it's not specific enough. It's going to be a bunch of different combinations that can, thank you, nice job, Peyton, get me to that combination of for 13 bagels. Okay, so this guy is not going to be a function. Nice job on that, guys. So now what I want you to do, now I want you to push yourself on the next slide. We're going to look at slide number 3. Now, what I want you to do, listen closely, is I want you to create a table, but this time, I want you to come up with the combinations that will be the best price. Best price meaning what? If we're talking about, I'm looking for the best price, what does that mean?
The lowest amount.
The lowest amount. So what's the lowest amount that you could pay for each one of these combinations of bagels? So I want you to take, I want you to take 2 more minutes right now to see if you can find and calculate the lowest best price for each one of these numbers of bagels. Does everyone understand what I'm trying to say here? Using this price list, I want you to say what's the best price that you can pay for each one of these number of bagels. You're taking 2 minutes right now. Let's get started. Once you finish, put the price for, let's start with, I don't know, we'll go along the way. Yep. Nice job, Peyton. I love it. Taking another 44. Once again, you're probably not going to finish the whole thing. But I actually think you can if you're being strategic about it. Yes, Peyton, that's fine. Another 7. Did you get all 13 done? Oh my gosh. Let's see. Okay. So when you buy one bagel, there's really only one way that you could do it. How much is one bagel going to cost you? $1.25. Very good. Okay. When you buy 2 bagels, how much is it going to cost you? $2.50. Nice job, everyone. Thank you for that, Connor. Okay. 3 bagels. How much is that going to cost you? Thank you, Gabe. $3.75. Okay. 4 bagels. $5. Because you can only buy single bagels up to 6. Good. So it's going to be $5. Now when you buy 5 bagels, nice job, Peyton and Abby Wasta and Connor, $6.25. This is where it's going to get a little bit funky donkey. What is the price for 6 bagels? Max, this is where we have a little bit of a discrepancy. We have $6, we have $7.50, we have $6. How did we think, why did we say that it was only going to be $6? Because that's the best price for it. We're not trying to be like the shopkeeper and rip people off. We're saying, I want to pay the least amount of money for my bagels. I am very frugal. Let me see back in. Okay. So the best price for the 6 bagel is going to be $6 because that's where the next bracket of pricing comes into play. Okay? So then if we look at 7 bagels, what are we thinking about 7 bagels? We think it's going to be $7.25? Very good. Very good. Oh, wait. Yeah, okay, perfect. Nice job on that one, Max. And Connor and Sean. There we go. Junior. 8 bagels. How much is 8 bagels going to cost us? $8.50. The best price for the bagel for 8 bagels, just like Gwen, Max, Nassim said, and Connor, is going to be $8.50. Very good. Now, this is where another bracket comes into place. What's the cheapest price for 9 bagels? Let's see what people are thinking at home. Very good, Nassim, Gabe, Gwen, Max, and Connor. It's going to be $8. So if you were trying to have a party and you were going to buy, and you had to buy like bagels for 8 people, how many would you guys buy? I'd buy them too, just because you get an extra bagel for like cheaper. Right? You buy like 12? Okay. Let's see, 10 bagels. How much is 10 bagels going to cost us? Nice job, Nassim. Ooh, Nassim is on it this morning. $9.25. Now 11 bagels. $10.50. Very good. Awesome job. Next one is 12 bagels is going to cost us how much money? $10, because we go up to that next price point here of 12 bagels cost me $10. Very good. And then 13 bagels, best price for 13 bagels is going to be $11.25. Very good. So we talked about in the first category, like when we first were talking about it last slide, we were talking just in general, number of bagels and the output is price. Now we're looking at the number of bagels versus the best price. If we're looking at the input of the number of bagels and our output is the best price that you can pay, how many outputs are there going to be for each number of bagels? If you're looking at just the best price. Very good, Gabe. Gabe, why do you say that there's only going to be 1? You can unmute if you want, buddy. Okay, very good. There's only 1 best price. There's not going to be 2 best prices. You're going to say the best price, the lowest price. There's only going to be 1. It's going to be $2.50. It's going to be $10.50. It's going to be $10. So when we're looking at these different phrasing of things, price versus best price, that could be the difference between function, non-function. Okay. Nice job on that, guys. Let's take a look at the last few sort of summation questions. Okay, so now let's look at, what did I get? Oh, there we go. Okay, so let's take a look at these different tables that we could have created for these 2 different ways that it was posed. So this first half over here is talking about when you pose the question, when you're looking for an output of just price. You're not specific, you're just looking for a price that you could pay. When we look at and we're more specific and we say best price, this would be our table that we would create of prices that we would get. Let me turn this down. What was it?
I said, don't buy off the shopkeeper. He's a scam.
I know he's a scammer, right? Do not go with the shopkeeper price. He is a scammer if you buy more than 6 bagels. Or more than 5 bagels, really. Because it would be the same. Good. So if we're looking at this, these 2 different ways that it's posed, what do we notice about this price sort of category here? For each input, what do we notice about those outputs for when we just say that word price? For some of them, how many outputs do we have? We only, for the first couple, we only have one output. When we get down to 6, what do we notice about the outputs then? There's 2, there's 3, there's 4. If it keeps going on, it's probably going to keep going and having more different combinations, right? So if we think back to that concept of function, non-function, there were 2 pieces that we talked about when we were talking about a non-function. Number 1, we really stressed was that you can't have repeating inputs, or you can't have different inputs with the same output. What was the other piece that we said also made it a non-function? If you had an input with what? So if you have 2 inputs with the same output, yes, that's number 1. Number 2 was we talked about if we have one input with what? Multiple outputs. Our focus today is going to be when we have an input that have multiple outputs, it's not going to be a function. Okay? So if we look at best price, if we pose this question of best price, what's the best price for these bagels? Is that one going to be a function? So best price is going to be a function. But if we're broad and we just say price, what are we going to say about that one? Non-function. Yes, very good. Non-function. Up to after 5. Does everyone at home see what I'm saying? What I'm getting at there? So before we were focusing on we can't have 2 different inputs with the same output. Today we're going to focus on that second piece where you can't have an output with more than one input with more than one output. That's not going to be a function. When you have an input with more than one output, it's not going to be a function. Let's take a look at what these graphs would look like if we were to graph them now. Okay? We're going to be talking about discrete points on these graphs as opposed to straight lines because we can't buy 0.5 of a bagel. Just an FYI. Let's look at some questions first. The number of bagels and price did not form a function, but the number of bagels and the best price forms a function. Why is that? Gabe already said it. Kyle? Good, so if you just say price, you're going to have multiple outputs. If you say more specifically best price, there's only one best price. Very good. There's only one best price. If we graph the relationship between the number of bagels and price, what do we think the graph would look like? There'd be multiple lines, exactly. Because there's different, it sort of branches off depending on how many or what price you use as that base price. Good. Now, last one. If we were to graph the relationship between the number of bagels and the best price, what would we notice about that graph? Kyle? It would be one line. Good. And I'm not going to say one straight line because we're going to notice some things when we actually look at the graphs on the next slide. Okay? So, nice job, Peyton. Let's look at the graphs now. Okay? So this one with all the colors is the number of bagels versus the price. This black and white one down here is the number of bagels and the best price. So we notice that if we were dealing with, what do we notice about these graphs first of all? What's one thing that you notice? About maybe the points, about anything. What do you notice about the graphs here? So the points make a straight line, okay? What else do we notice? the second graph isn't straight. Good. Yes, Gabe, very good. Let me just mark one friend in. Perfect. Okay, so it's not going to be straight. John, I have a question for you. Let me ask you a question. So I'm looking at both of these graphs and I just have like points. They're not connected with lines. Why do we think that we have, we call them discrete points as opposed to lines here? As opposed to, like, why aren't we connecting those points, John?
Because it doesn't always go up on the same amount.
Well, I mean, if like this one here is going up all by the same price, but why do we have discrete points as opposed to like connecting all of those points? We talked about this in previous units. We can't draw a line in because can I buy, let me ask a question, can I buy 8.5 bagels? Well, do you think a bagel shop would sell a half a bagel?
No.
Maybe, maybe not. We're going to say no for this story. We're going to say no for this story. So you can't buy half a bagel. You can't buy a quarter of a bagel. So the reason we have discrete points here is because these are points that you could buy. These are numbers that you could buy. You can't buy pieces like half a bagel, a quarter of a bagel, okay? So what if I were to say, if I were to look at 7 bagels, what do we notice about the outputs on the 7 bagels? There's 2 different outputs, right? And we can't say that we have a function if we have more than one output for each input, okay? So let's move forward and let's look at our learning targets for today, okay? I know that we spent a lot of time on that, but I was supposed to spend a lot of time on that. Let's take a look here, okay? Number 1, I can explain when a relationship between 2 quantities is a function. So you know the 2 ways that it is a function, 2 reasons that we would call it a function. Number 2, I can identify independent and dependent variables in a function and use words and graphs to represent those functions. Okay, that's a lot of information there. I can make sense of descriptions and graphs of functions and explain what they tell us in a situation. This is probably, this is where I'm going to be using that term that I've always been using, context. What does it mean in the context of this story? What is this graph telling us when we look at the labels on our axes? We can pull information just by looking at axes of graphs, okay? So our activity for today, our first activity for today is called Be Right Back, TTYL. 3 days in a row, a dog owner tied his dog's 5-foot leash to a post outside a store while he ran into the store to get a drink. Each time the owner returned within minutes, okay? The dog's movement each day is described here. On day 1, the dog walked around the entire time while waiting for its owner, okay? Day 2, the dog walked around for the first minute, then laid down until its owner returned. Day 3, the dog tried to follow its owner into the store, but was stopped by the leash. Then it started walking around the post in one direction. It kept walking until its leash was completely wrapped up around the post. The dog stayed there until its owner returned. Okay? So, 2 other pieces of information that we know. That is so annoying. That would have gotten cold. Okay, another piece of information. Sorry guys, that's okay, Nassim. Each day the dog was 1.5 feet away from the post when the owner left. So every day it starts at 1.5 feet away from the post. Each day, 60 seconds after the owner left, the dog was 4 feet from the post. So let me tell you what our job is going to be now. Okay, so our job now is going to be creating graphs based on these descriptions. So let me show you what we're going to do. We're going to do this first one together, and then you're going to do one of them that I'm going to assign to you. So let's go down to slide number 9, and we're going to look at day 2's description. Okay, and I put the description right down here on the bottom of the slide, so you don't have to keep going back and forth. What are two, if we think back to that last slide, what is the first data point that I can put on this graph? I know one data point for sure. Guys, stop clicking, eyes up here. What is one data point that we know for sure that I can put on this graph? Kyle Kelly.
Ms. Burnett, please call extension 3211.
Kyle said 0, 0. Okay, so Kyle said 0, 0. At 0 seconds, he's 0 feet from the post. Do we agree? Look back at the description, guys. Each day, the dog was 1.5 feet away from the post when the owner left. So it shouldn't be at 0, 0. It should be at 0, 1.5. So grab one of these points off the pile. Put your point at 0, 1.5. What's the other piece of information that we know? Peyton, what about that 60 seconds? Wait 1 second. After 60 seconds, what do we know, Peyton? Nice. Oh, nice job, Gwen. After 60 seconds, how far was he? Very good. He was 4 feet from the post. So that's our second point that we can put on here. Now we need to fill in our lines here based on the story. So it says day 2, the dog walked around for the first minute, then laid down until its owner returned. So if we look from this little segment right here, because that's where a minute is, what can we put for a line here? Or how would we fill it in? You could go straight. You could connect these 2 points. Very good. You could put a line in like this. When I read this description myself earlier, I actually went like this. I drew a line in like this because it just said he walked around. So you could make a straight line like this guy here that as long as he's constantly moving, that would be okay. Whether you draw a straight line or a nice little curved line like I did on my paper when I did this myself. Okay, so what you need to do is you need to hit the little line button and insert a line for yourself. You can make it funky donkey, you can make it straight, however you want to depict that idea of walking around. Okay, so then after, okay, then for the first minute, and then laid down until its owner returned. So what's going to happen after that 1 minute mark? What's not going to change? The distance isn't going to change. So it would go straight across. Very good. So you're going to grab another line like this off the, so you're going to come here, you're going to go line. And now it's going to have to be flat or horizontal until all the way on the end. Because he's not moving, our distance is not changing. Very good job on that one, guys. I did 2 different colors. You can leave it literally just the line. You can make the colors, whatever you want to do. Okay? You can be creative with this. You can just sort of simplify it. That's okay. So now what I want you guys to do, listen what I'm going to ask you to do. I would like you to look at, I want you to take, let's see, I want you to take 4 minutes right now, okay, to create a graph for day 1's description, And then I also want you to try to make a graph for day 3's description. Day 3, there's a lot there, so try your best. I want you to take 4 minutes right now to do these 2 other descriptions. Day 1 first, right? Everybody at home understanding what we're doing? You can be creative with it. You can be like not creative, like you can just do straight lines. It's up to you, okay? As long as you're depicting what it's telling you. Perfect. Thank you, Max. Thank you, Gabe. Remember that you, on all 3 of your graphs, you need to put those start values at 1.5 and then the one at 60 seconds and 4. Thank you, Kyle, for that, buddy. Okay, we're taking another minute and 37. If you finish early, let me know in the chat. Another minute and 2. You're doing great. So Tyler, you were able to get in and working, right, buddy? Another 31. You guys are doing great. Keep it up. So he walked, so he did something up until the 60 seconds, and then after 60, he started to wind himself up. Okay. So let's talk about it now. Okay, so we're looking at day 1. What is your graph? So it says the dog walked around the entire time while waiting for its owner. So this one was really broad. You could have done a couple things to show this. What did you guys do? What did you guys, who wants to just sort of describe? Can I have Max? Can you unmute and can you tell me how yours looks here? Hi. Sure, yeah.
Sorry, what did you say? I didn't hear you yet.
Oh, that's okay. So what I'm gonna have you do is, can you look at your day 1 graph and can you explain to me what does yours look like so that I can sort of make it look like yours on mine?
So I had the first 2 points like you did, and then I had 1 point at 5 and 80.
Okay. So I connected it like that, okay? Then
I
what?
had 1 point at 2, 100.
Okay,
1 point at 5, 140.
okay,
And then 1
Good.
point at 4, 160.
very good. So what was one thing that we had to make sure we didn't have here? When we had our graph here, Connor.
Oh, going like the same distance and staying there.
Exactly. The dog's distance always had to sort of change because he's not ever going to be in the same spot or the same distance, even if like he's moving like a centimeter, because he's always moving. He's never going to be at the same distance or at the same time. It's never going to even off like it did before. Good. So you could have done just literally something like this. You could have, well, actually, I would connect it all the way down to 160, but you could have done really anything for this one. This one was more create your own story type deal. Okay. Now this is where the last one gets a little bit tricky. Okay. If we slip and slide down to slide number 3, let's look at what this description was. Okay. It says the dog tried to follow its owner into the store, but was stopped by the leash. So what does that mean happened on your graph here, Max? Or Connor? Whoa.
The dog goes to the maximum distance.
Which is?
5 feet.
Okay. And like, how did you make it like that? Or, like, did you make it like a steep? Because
I did the point at 1 or 0, 1.5, the other one at 60 and 4. But then I brought it up to 580.
Okay. So you're saying like he maybe followed his owner a little bit slower. Okay. So like he was like, I'm gonna like try to get there. I'm gonna get to him. Okay. Okay, go ahead.
I put another point at 4, 100.
4, 100.
Because it stops and then it goes around and gets tangled.
And then what's happening as he is getting tangled? What's happening to the distance that he can go? Very
So
good.
then I put a point at 3, 120.
3, 120.
And then 2, 140.
Okay.
And then 0, 160.
Very good. So basically what is happening when his leash, when he's walking, so like the line isn't going to go like around, you're not going to make a circle on your graph. It basically, when his leash is getting short, or when he's going around the pole, the leash is wrapping around, so then he has less distance that he can go. So he's going like this, but then he's getting closer to the pole. So like this is my pole. So like he starts out here, and as it wraps around, he gets closer and closer and closer to the pole because he has less leash to work with, right? So as long as you have it going down, then you're going to be good to go. And you want him to be following up until he hits the end of the rope. So he needs to make it at some point to at least 5 feet. Okay. So in this graph, you have to hit the 5 foot mark because he hits the end of his rope. Then, because he is like shortening his leash, his distance is going to come in closer to the 0. Does that make sense, you guys? Do you see why that is, Gwen? You could have, like if you said, if he's not sitting like literally on top of the pole, you could have like stopped him here, like half a foot from the pole. That could have worked as well, okay? But I would still take that 0, all the way down to 0. Okay, does that make sense, guys? Okay, good. So let me tell you what we're going to be finishing up with for today. Okay, so if we look at the next piece of this here, this is now on you. You're going to be making some decisions here. So here are 2 pairs of quantities from a situation you've seen in this lesson. Each pair has a relationship that can be defined as a function. Okay, so each of these is a function, can be defined as a function. Okay, number one, the first one that you can choose from, time in seconds since the dog owner left and the total number of times the dog has barked. Or two, time in seconds since the dog owner left and the total distance in feet, that the dog has walked while waiting. You can pick one of these two scenarios. What you're going to do once you pick one of those scenarios is number one, you're going to identify independent and dependent variables. Independents are our what? What's another synonym for independent variable? Synonym, same meaning as independent variable. The cause and effect, if we're talking about independent versus or input versus output, very good, Gabe. It's going to be our input. Okay, so independent variables are in, they're going in, you're plugging them in, inputting them. The dependents depend are the answer, they depend on what you input. So it's going to be our dependents are our outputs. Does that make sense? The difference between independent and the independent and dependent as connected to inputs and outputs. Do we see that? So first you're going to identify the independent and dependent. Then you're going to, this is not too bad for you guys, write a sentence in the form of blank is a function of blank. And then you're going to create a graph on slide number 13, labeling your axes, scaling them, and putting some points on. You can grab points from the pile on slide number 11. Okay, so I want you to take 3 minutes right now to do these 3 things. You might not get through everything, that's okay. Very good, Gabe, on that one. I already said that, but. So like I said, if you need points for this, you can come back to 11. And what I am going to do is I'm going to come over to this pile here. I'm going to grab them. Control C. And then I can throw them on here to put some points on. Nice job, Peyton. That's a specific statement. Make sure that you're giving me a broad sort of without value. What is a function of what? Height is a function, height in feet is a function of height in centimeters. That's a terrible conversion, but. So give me more of a broad, when we're talking about functions, you give me broad, not specific data values. Does that make sense, Pete? You can look at the questions on 14 and 15. Yes, we're going to go through them together. Okay. We're going to take another 34 seconds and then we're going to come back together. You can start to look at those questions on 13 and 14 if you'd like. Or actually, I think just wait, let's see. Yeah, you can start to, yes, I broke the questions onto 2 slides. Good. So you're thinking when you're looking at 13 and 14, it's sort of, or 14 and 15, it's like backwards. You're thinking like maybe like, let's see what happens. Okay, let's come back together. 3 and 1. Okay. So what were my independent for both of these? We would still get the same independent. What was our independent variable or our input here? What were we talking about that input logically? Very good, Gabe. He said time in seconds. Very good. That is going to be the same for both of them. And why did we say the time in seconds was going to be the independent or the input here? Yeah.
Because they're putting the seconds in to get the dog barks for the.
Very good, because the number of barks, the total number of feet depends on the time. The time doesn't depend on the number of barks or the total number of feet. You're thinking about it, what depends on what? The total distance depends on the time. Output depends on input. Very good. So then what were our outputs here? What was one of them if you chose the first one? John, what did you say your output was? Very good. Total, distance, and feet. Good. What was the other output value if you chose the other one? Number of barks. Oh, I just said it. The other dependent or output would be the total number of barks. What is a function of what here? Abby Wasta, can I have you on mute? Tell me what is a function of what for this one, for the one that you chose?
I said that the total distance that the dog walked is a function of the time the owner left.
Very good. Total distance is a function of time. Good. If you were looking at the number of barks, how would you write that function sentence? What would it be? Who did barks in here? Barks? It would be the total number of barks and then I'm going to say is a function of the time. Very good. The number of barks, the total feet, is a function, depends upon the time since the owner left. Good. So now, we just said total distance is a function of time. Total number of barks is a function of time. Now we're going to look at some questions on the next slide that are going to switch it around. Let's see. We're going to look at it the other way, switch the outputs and the input, not values, but quantities, and we'll see if it's still going to get us a function. All right, so for your graph here, you would go, what did you put down on the X? Time. And you could have written distance or number of barks. Okay. You could have, I just labeled it 5, 10, 15, 20, 25, 30, 20, 40, 60, 80, 100, 120, 140, 160. Okay. This was really up to you. In general, what way was it going? It's going up, right? Wait, I went wrong way. Good. could be times, there could be like, where like he had the same number of barks as like, he would go like, he could have like from a minute, 100 seconds to 120 seconds, he could have had 27 barks and he didn't like bark at all, or he didn't move his distance at all. And it would like taper off like that. Good. So you just want to put points on here, but make sure that you don't ever, so like, for example, what if I was looking, let me put one right here, right? What if I put another point right here? Could that logically make sense in this story? He was at 80 seconds. He had 24 barks and 17 barks. Does that make sense? No, it's not logical. So you need to make sure that your graph does not, the important piece, your graph cannot have, if you're drawing a vertical line in, it cannot have more than 1 point on that vertical line. So this blue point would not work here. It would be illogical in the context of the story. Does that make sense, you guys? Good. Very good. I'm going to erase. I'm going to be pulling this up for the warm-up tomorrow. I'm going to be pulling up this graph and this scenario. We're going to be discussing. This discussion on the next slide is important. So I'm going to be migrating it into the next slideshow. You can turn it in for now. Your homework for this evening. Listen closely. Homework for this evening, 15 minutes of Alex if you didn't finish your time for the week. If you finish the time for the week, you are all set. I mean, maybe look at your topic goal, make sure you hit your topic goal. But I need 15 minutes of Alex time if you did not reach your max for the week. If you reach the max, then you're going to be exempt from this homework assignment. Okay? Does that make sense? You guys can head to Spanish. I will see you in a little bit. Have a great rest of your day. Yes, I'm going to write. I have to hit the publish because I put them in like a week ago, but I didn't publish them because they people hadn't finished, so they will get published today. I just have to click a button, Peyton. If you are still in, if you don't go to Spanish, I need you to open up your Alex, get some time work in there, and we will be moving on from there. Okay? Take some time in Alex for me, please. Oh, I have a missed call. When did I get a missed call? What? When did she call me? Darn. Okay, nice job, everybody. Ooh, you know what I'm gonna do? Minimize. Oh, I want to stop my recording.